Hello, this is Dr. Wyatt, and we are working on homework number 8, and this is the homework number 8 help video. I apologize for not being able to make the Zoom meeting this week. Breaking a finger is real inconvenient. So, we are looking at dice. My favorite way to do this is to put the possibilities from the first dice here and the possibilities from the second dice here, because we are rolling 2 dice together and adding their faces. So if we add their faces, you end up looking at a table that looks like this. This is something I would put in my notes so I didn't have to recreate it if I'm taking an exam. It doesn't take that long to create, obviously, but it's kind of a nice thing to just have in your notes. Wouldn't bother memorizing these numbers or anything. It doesn't seem to make a lot of sense. Probability of an 8. 1, 2, 3, 4, 5. 6 times 6 is 36. 5 out of 36. Probability of getting doubles. 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s. There's 6 of those. 6 out of 36. Probably getting a sum more than 10. 1. More than 10. Whoops, not 10. 1, 2, 3. 3 out of 36. Hey, there you go. And they want these in decimals, so just use your calculator and figure out what the decimals are. Make sure you're rounding correctly. The next question we had was on question number 11. In a large population, at least 51% have been vaccinated. 4 people are going to select it. What's the probability? At least 1 has been vaccinated. Now, I've gone over this before in videos, but I want to make this super clear. At least 1 is always 1 minus the probability of none. Why is that? Well, if I had 4 people, all right, the number vaccinated, that's X. The number vaccinated could be 0, could be 1, could be 2, could be 3, could be 4. Each one of these is going to have a probability associated with it. Right? The probability of 0 vaccinated will be some number here, some number here, some number here, some. At least 1 is these 4 added together. All of these added together is the entire universe, so it adds up to 1. So instead of adding these 4 together, I figure out what this is, and I subtract it from the 1 because that's easier. So what is the probability if I have 4 people, none of them are vaccinated? Well, if 51% of the population is vaccinated, then 49 is not. So the first one is not vaccinated, and the second one is not vaccinated, and the third one is not vaccinated, and the fourth one is not vaccinated. So that, when I use my calculator, 0.49 raised to the 4th power is this. That's the probability none are vaccinated. 1 minus that is this. Going to 4 decimal places, 4, 9, 2, 3, 5. So 4 decimal places, 0.4924. All right. All right. So next question was 12. Each of the following probabilities is a probability of the Amarok stock event A rises, and the probability that Best Buy stock rises. Write each of the 4 accurate. The probability that either A or B rises if the 2 opponents are independent. All right, so independent means that they don't affect one another. It's different than mutually exclusive, but A or B, the probability of A or B is the probability A plus the probability of B minus the probability that they both rise, right? If they're independent, the probability that they both rise at the same time is just the probability that A happens and the probability that B happens, right? So what I'm going to have here for this is 0.412, that's this stock, plus 0.375, that stock, minus the probability of them both happening is 0.412 times 0.375. Now I take out this both because I counted them. It's like the intersection. When you're doing it, you count them twice. So if I go 0.412, sorry, I said 5, plus 0.375 minus 0.412 times 0.375, and this would be there. Right? Find the probability that B does not occur. Well, that's the event that is just, so the probability that B does not occur, probability of not B is equal to 1 minus the probability of B. So that's just 1 minus 0.375. Okay? Probability that both A and B occur if these two events are independent. We figured that out right here already. That's this number right here. Probability that either A or B occurs if these two are dependent, and the probability that both is this. All right, so if they're dependent, then it's going to change. Like this going up affects that going up and so on. And they give us this. It's the same formula that we have already looked at right here, just with a different number for the both because they're dependent. And they gave us that number. If they didn't give us that number and told us it was dependent, we would not be able to figure that out without further information. But they gave us everything we need there. So now we're going to take the probability of A plus the probability of B minus the probability of both, which is equal to 0.412 plus 0.375 minus 0.184. Okay, probability event A does not occur and event B does not occur if these two events are independent. If they're independent, then it's the probability of A and B is just equal to the probability of A times B, right? If they're independent. So if I want to find that they both occur, then, or does not occur, I'm looking for the probability of not A and not B. What's the probability of not A times the probability of not B? Not A is 1 minus 0.412. Not B is 1 minus 0.375. I just multiply those together and I get that answer. And now we are on 14. It says use the Venn diagram to show the probability. So what I'm looking for is the probability of A intersect B or C. Right? So where's B or C? Right here. First I need to know how many there are on a hurdle. That kind of throws people. A lot of people don't see this 3 right here. So we have 13 plus 5 plus 1 plus 8 plus 15 plus 4 plus 12 plus 3. I get them all? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we've got, adding these up, 61. All right, so 61 total in our whole universe. And then we went B or C. So B or C, that's all of these and all of these. Okay. Intersecting those with A's. So they also have to be in here. All right. So this is going to be these guys in here. So I have 5 plus 1 plus 8, which is equal to 14 over 61 for the probability. That's the answer there. All right, moving on, the next question was 14, it was 15B. All right, so selecting red or purple. All right, that's probability of red plus probability of purple minus probability of both. Last time I checked, we couldn't have both red or purple Skittles. So it's just the number. Selecting, all right, so we have red, 9, purple, 12, total of 21, out of how many total? 9 plus 8 plus 10 plus 14 plus 12, 53. So 21 out of 53. All right, so that is B. That's the only one that was requested there. Just go 2 consecutive orange Skittles, just because this is a good problem to know. The first one is orange, is 8 out of 53. And the second one, without replacement, 7. There's only 52 left. Okay, multiply those out, and that will be your probability. Moving on to 17. Survey groups' habits are the following. Find the percentages that visited none of these 3 sites last month. All right. So if we think about it, we can make this into a Venn diagram, we can make it into a table, or we can just think it through. So none of these 3 sites. So let's go ahead and let's try a Venn diagram. Facebook, LinkedIn, Google. All right. 30% visited Facebook. All right, let's start from the beginning. 5% visited all 3 sites. That's what goes in there. All right, 13%, okay, let's call this Facebook, and then label them Google. All right. So, moving on. 13% in LinkedIn and Google. Right? 11% in Facebook and Google. 14% visited Facebook and LinkedIn. Right. Now, a total, no, wait a minute. This should have been counting. We need to take that 5% out. We counted it twice. So this isn't 13 because there's a 5 here. This is actually 8. Now it adds up to 13. This is actually 6. Now it adds up to 11. This is actually 9. Now it adds up to 14. Right? Now we want Google to add up to 31. So if I take 31 minus 6 minus 8 minus 5, there's 12 that only went to Google. Right? Now if I do 36, LinkedIn, 36 minus 9 minus 8 minus 5, 14 that only went to LinkedIn, not the other 3 sites. And then if I do Facebook, 30 minus 9 minus 5 minus 6, 10. Right? Question is, how many went to none of these 3 sites? So I'm going to add these I'm going to add these 1, 2, 3, 4, 5, 6, 7 numbers together. So I've got 10 plus 9 plus 14 plus 6 plus 5 plus 8 plus 12. And I get 64. That means that's all together. 1, 2, 3, 4, 5, 6, 7. 6, 7. 1, 2, 3, 4, 5, 6. I got them all together. Good. 64% out of 100. So that means this is 36%. That means out here there'd be a 36 because it has to add to 100%. So that's one way to do it. There's lots of different ways to do it. That is one way to do it. All right, number 18. Actuaries studied The likelihood that different types of drivers had at least one collision during any given year, the results of the study show here. So probability driver with at least one collision is a senior driver. Okay, so this table that they've given us is kind of not complete. And because it's not complete, it's a little hard to see what's going on here. So let's complete it, right? If 14% of all the drivers, so this adds up to 100 here, are teen, and 17 of those teens have an accident, 17% of those teens have an accident, then the actual percentage of teens that are having accidents are 2.38. Right? That is 14 times 17. Now, 25 times 0.07 is 1.75, so 1.75% of young adults have an accident. 44 times 5 is 2.2, so 2.2% of middle-aged adults have accidents, and seniors is 1.35. So we need to complete this part first because it's just not done. This is actual accidents if you've had them in 1 year, actual percent of accidents. Right? So that happens there. And then let's add these up. Now this is 100 here, we know that. Let's add these up, and when we add these percentages up, we end up with getting 7.86. Now that we have this table actually complete, we can ask the question. It's pretty easy. Find the probability driver with at least one collision. That's out of this crew right here. It's the actual accident table here. In the last year as a senior driver. So there's 1.3% seniors out of 7.86, and that's the answer that they're looking for. Moving on to problem 19. If you have an urn, which is just a jar, with 185 sets of paper, each one of these bears the number 1 through 37 5 different times. Child selects 2 papers out of the jar, takes them out without replacement. What's the probability to have the same number? So let's think about this. We can write this as reduced fractions. Now there's several ways to do this, right? Let's just say, what's the probability they're both 1? Well, there's 137. There's 5 ones in there out of 185. Right, which is 1 out of 37. And then after they take the first one out, then there's 4 ones out of there, out of 184. All right, so that's just to get 2 ones. Right? But then you could also get 2 2s, 2 3s, 2 4s, all the way up to 37s, and those probabilities are all the same, so you can just times that by 37. So when you do that, you take 37 times 5 times 4, divided by 185 times, put this bottom in parentheses so they're both in the numerator, or the denominator, and you should get 0.021739130. Right. But that's not the only way to do it. That's just one way. The other way is to say, okay, well, there's 37 numbers. I have to choose one of them, times, and then there are 5, there's well, it's the same, and ends up being exactly the same. Then I have 5 ways of getting that one number out of 185 times 4 ways of getting that number 1 out of 184. So that works as well. All right, and number 20. Urn contains 17 red, 40 white, and 28 blue marbles. The child selects 2 marbles without replacement. Then we're going to find the probabilities that the selected marbles are different. Okay, so let's just think this through. What are my choices? Right? Let's just add the choices. Let's say I pick a red first, or a white first, or a blue first. All of this is just kind of, there's no like, all right. If I pick a red first, I had, well, first of all, what's 17 plus 28 plus 40? 85. So there's 85 total here. So I had 17 out of 85 chance of getting a red. And then to not get red, now I took one red out, right? So now there's only 84 left in there. I need to not get the red, and there's 68. 68 that are not red because 40 plus those are white and blue. Right? So I can do that one. That's if I get red first. What if I get white first? I have a 40 out of 85 chance of getting white first. And then to not get a white, that would be 17 plus 28, 45. All right. And then blue. If I start with the blue, 28 out of 85 chance of starting with the blue. And then to not get a blue, next, there's only 84 left because I took one out without replacement. 17 red left in there and 40 right, so that's 57. Okay. I multiply these up and add them together. And that should give me my answer. And 22. All right, it says, find probability of B given A, which by our formula is the probability of B and A divided by the probability of A. So, probability of B and A, 0.1 divided by A, 0.25. That's the fractional setup. And then to do decimal places, 0.1 divided by 0.25, 0.4. All right, probability of A given B. By our formula, that's probability of A and B divided by the probability of B. So that is A and B, 2/15 divided by, and probability of B, oh, this should be 3/10. And notice that one right there. That's 3/10. Right? And then that's your fraction setup. You can reduce that fraction and then to two places. Okay? If these are the same, if 2 divided by 15 was the same, then they would be independent, but they're not. All right? And that's because if they're independent, then the probability of A is equal to the probability of A given B. That given B does not change the probability of A, and that is not the case, right? So, all right, and that is the last one that was on the questions. If you have other questions, please let me know. Thank you for your patience, and have a great weekend and a wonderful holiday week. Thanks. Bye.